All right, so we're gonna do the quotient rule here. The bottom times the derivative of the top. What's the derivative of ln x? 1 over x, is that 1 over x? Minus, bottom times the derivative of the top minus the top. Times the derivative, minus the top. Minus the top. Times the derivative of the bottom. What's that? What's it going to be? Negative 1? The derivative of the bottom. Okay, all over the bottom squared. So, if this is like a free response, FRQ, and it says to find the derivative of this would be, you'll be done. This is it. You don't have to complicate things anymore. That would be it, no? But if you had to simplify, we could simplify. What are we going to continue on? But let's see, what can we simplify here? Well, if you multiply it out, yeah. If you multiply, like if you distribute this right here, then you're gonna get what is that? 1 minus x. Well, why would you? It's 1 over x and what? Minus 1, because they're gonna cancel out right here, and then here that's gonna be a positive ln x, and then over 1 minus x squared. Again, if you don't want to see a 1 over x here, you can multiply just the top by x over x. Because x over x is just 1. So distribute this all the way through f prime of x. Then you're going to get, the x is going to cancel. Well, it's going to be over x squared, though. It's not going to do anything. But hold on. No, it's not going to do anything. What is this? Then, well, not there, but the whole thing. Yeah, not there. See? Let me erase it. The whole thing, not just that, but the whole thing. X over x. Then this is going to go like this. Then you could distribute this x for the top, and then that's going to cancel out here. I'm talking about just this x right here. So that's going to give you what? 1 minus x, and then plus x ln x. And then the bottom would be x 1 minus x squared. And this is kind of like, I think this would be the one answer that would be on a multiple choice. Why don't you guys put it on your calculator, see what you get. Put it in calculator, f prime of, do f prime ddx of this. What you get? What are you getting? It's something similar, but like I just said, it's enter. I got ddx of ln x over 1 minus x. I got ln x, then it's still not simplified. Let me see, enter again. Does it simplify more? Nope. Are you guys getting this? Ln x over x minus 1 squared minus 1 over x times x minus 1. Is this what you guys getting? That's what I'm getting on the calculator. ln x. That's what I'm getting. What do you guys get? Just put it in there. You getting this? So is that this? We could play around with it. It probably will be. Look. Look. Let me just. I'll just take time to do this one. We need a common denominator here, no? So how many x minus 1s are there here? 2 of them. And how many are there here? 1. So you can go ahead and do x minus 1 times x minus 1 on top and bottom. And then now you got your x minus 1 squared, but that one has an extra x, no? So then you put an x here, no? Now we have a common denominator, no? So you can have x times x minus 1 squared. Okay, and this is going to be x ln x. And this is, distribute this negative, will be negative x, positive 1. So x, 1 minus x squared. You got your x ln x. You got your negative x, and you got positive 1. Yeah, good. So when it comes to this now, you're gonna have to. There's no. It's not as simple as this, no. Where you're like, can you just show me what is the answer to this? Or like, I don't know, I'm making up. You just divide by 4, and the answer is 1/2. It's simple. But when it comes to more complicated, there's different forms. Like right here, the way I have it in the PowerPoint, I used. I'm gonna use product rule because I'm moving this to the top. It's 1 minus x to the 1 power. Move it to the top, and then you do product rule. I think it's more. I don't know. It's on you. What do you think is more complicated or less complicated? Moving on. Higher order derivatives. Let's go to the lesson for today. So you can keep on taking derivatives. We've just been doing first derivatives, but then it could keep on going with the derivatives. So if you're given a notation of y, you can go ahead and take the first derivative of y, and that's going to be what? Y prime. You get an answer for that first derivative, and you can take that second derivative of this, and it would be y double prime. Then you, if you got something other than 0, well, you can take the derivative again of y double prime to become triple prime, whatever, I don't know, third degree. The third derivative will be y triple prime. Third derivative. And then you can just keep on going on the fourth, fifth derivative on. So if you're using this notation of f of x, you can go ahead and take the first derivative, and it will be f prime of x. Then you take the derivative of f prime of x, and it becomes f double prime of x. And you can take the derivative of f double prime of x, becomes f third prime of x. On and on like that. We're going to have that notation of y. What's the other missing one that we're going to have here, you think? What are the main notations we've used? It's called the Leibniz notation, or yeah, Leibniz. Which one is it? What's going to be right here? Anybody? Come on. dy dx. dy dx is the Leibniz notation. So the first derivative, and then we're going to do dy dx, the second derivative of dy dx, the third derivative of dy dx, the nth derivative of dy dx. So to connect this to to something in real life situation. Say for example, you got this first derivative notation to be like speed. No, not speed, but position. Y equals something, no? Y equals some function. Y is equal to f of x, f of x. Let's say that f of x is a describes position of something. And if you take the derivative of f of x or y prime, y prime is f prime of x, then this will be describing what? Velocity. And if you take the derivative of this, y double prime, it'll be what? Are you guys taking, you taking physics, no? You guys taking physics? And then you take what? The third derivative is f triple prime of x. Let's see. Extra credit if you tell me what it is. Nobody knows what that one's called? The third derivative? Jerk. It's like jerk. On like that. Alright, let's find the derivatives for the following functions. Easy. Power roll. Who's that? Okay, so yes. Let me let's have give me the first derivative. Hold on, this will be Rufus, what's the first derivative?
6x 5 subtract 8x cubed plus 10x subtract 8.
All right. Daniel, what's the second derivative? 30x what?
30x
To the fourth power? What? Oh, you're multiplying 8 times 3. So you know how to do the calculus, you just don't remember how to multiply your math facts? That's okay. So you do know what you're supposed to do, just you don't know how to get it. You over there in the back, Adan, what is it?
30x to the fourth minus 24x squared plus 10.
Right here in the front. Jacob.
120x cubed minus.
What'd you say?
120x cubed minus 48x.
Not here. America. Fourth derivative.
360x squared.
What? 360x squared?
40 minus 40.
Yeah. Is that enough? Is that it? Is there more? I mean, you can keep going until it goes to 0 or whatever. But we just stop in there for this. All right, look, what do you do, B? Why don't you guys do it by yourselves right now, B? Sean, what is the derivative of that one?
One over two square root of x plus -2x.
Over? Or are you putting it to the bottom already? It'll be negative 2x to the negative 3 power. You could put it in the bottom, but then we're going to take the next derivative, so maybe you could just leave it like that, no? X to the negative 3. Continue then. Somebody told me I keep calling you Tuger. It sounds cool, better. They say, no, it's not Tuger, it's Tuger. Is it Tuger? Oh, okay, that's what I thought. I think it's Tuger sounds better, but Tuger. What's the next derivative? And this one can keep on going on. I guess they all could. Next, let's go. Next. Let f of x equal that. Find f prime of x and f double prime of x. Go, let's go. That's easy. This would be like a easy point if this was on the AP test. That's too easy. Anthony, what is the first derivative? Huh? What's the second derivative? What's the second derivative? Who's that going to be? Vivian, second derivative. 6x. That's it. We're done here with this one. Number 2. Let's go to number 2. If dy dx is that, then the third derivative evaluated at x equal 2 is what? derivative. No, it's already the first derivative. We got to take the second derivative. Second derivative. 4x cubed minus 6x squared plus 3. Then we take the next derivative to get the third derivative. 12x squared minus 12x. And now we evaluate it at x equal to 2. That's going to be what, 48, 24 then? 24. Moving on. Next. Easy. These are easy problems. Next. Alright, let's go number 3. If y equals e to the 2 times sine x, then what's the second derivative? So e to the 2 sine x, and then you take the derivative of this. Derivative of that is what? It's times 2 cosine x. Then we take the next, we do the next derivative. ddx 2 ddx squared like that. So this is a product rule. Product first times the derivative of the second. Derivative of the second is negative 2 sine x plus the second times the derivative of the first, which is again the same we got there right here, because the derivative of the first, yeah, is this one right there. So we're gonna get this e2 sine x first. We can simplify this some more, no? Cosine squared x e2 sine x then we can factor out and we can factor out a 2. So we can factor out a 2. Yeah, again, you factor out a negative or not, doesn't matter. Let's leave it as 2 sine. Nope, because we're only factoring what out? 2e 2 sine x. So if I do that, then I'm going to be left off with a negative. Or if I do factor out the negative, then this will be positive then. So -2. Is that just going to be then 1? No, this is sine x, no? Sine x. And then here will be, that's going to be a minus. -2. Let's see what we got here. So there's the sine, yeah. Just gotta know how to match it. They're both the same, just that I factor out the negative as well. Number 4. Let's go to number 4. We're almost done here. We got 4 and 5, and we're done. From the beginning, I don't know, I'm already gonna move that y over to this side. So if, I don't know why, but maybe that's just the way I want to do it. And then do d dx of it. That's the way I want to do it. I don't know, you don't have to do it this way, but it's just. And now we take the derivative of this, and then that would be cosine y dy dx minus dy dx equal 1. Then we take the second derivative of these, this. This is a 2 here. Let's see, what would this be? The second derivative? So what's the derivative of cosine? Is that negative sign? Then we can factor out the second derivative. Uh-oh. How the heck this is going to be wrong? It's going to be 0 then, because if I'm going to divide it on the other one. Because if I factor it out and I divide it into here, it's going to be 0. So we run into a problem here. Let's see. The way I did it. The way I did it. This is the way. You could have just done it the way it is right there. So it is going to be 0. Hold on, hold on. Hold on here. So we're supposed to get the dy dx by itself and then take the derivative over it. So that was the mistake. Let's go ahead and write it. I could have done it. You could have done it the way I did it, but you had to get the dy dx by itself first. So we're supposed to get the dy dx by itself and then take the second derivative. All right, so remember this big lesson for today is if you have it in Leibniz notation and you want to go on, continue with the derivatives, you have to get the d dx by itself and then continue on taking the derivative. And this one looks to be like a what? You could do what? Quotient rule? Yeah, you could do quotient rule. I guess to not make it more complicated, just do the quotient rule, I guess. Or you can do the product rule or chain rule thing that I have here. But you can just do the quotient rule. Let's see, so if we continue on with the quotient rule, minus the top times the derivative of the bottom. So this cancels out, and we're going to get positive sine y. But what is dy dx equal to? Right here, no? So we can substitute what dy dx is. We already multiply this out. This is sine y, but you got to substitute in dy dx. And dy dx is this. Which basically, this is at the bottom, should be at the bottom as well. So there's 3 of them. So it'll be sine y over cos y minus 1 to the third. Last problem for today here, number 5. Let f be the function given by that on that closed interval from 0 to 3. What is the instantaneous rate of change of f prime at x equal to 1? So this could have been problem number one. But it's just understanding what we got to do is, what do we got to do for sure? Go to all the way to the what derivative? Not the first derivative. We got to go to the. Here's look. This is the understanding, and now this is what. If I with movement with position, didn't I say it was F was position, no? And F prime would be what? Velocity, no? F double prime is what? Acceleration. So this tells you something about velocity, the instantaneous rate of change of this. So what is the instantaneous rate of change of velocity? Would be the acceleration. Yes. I even when I was looking at it, I thought I got it wrong today. I was like, well, just take the first derivative, evaluate it. No. You gotta go to the second derivative. So f prime is 6x squared minus 10x plus 8. Take the second derivative and now evaluate it there. All right, so that is